Hi, my name is Akshay and this is Half Sleeves. This is a video series on how to make a style transfer model, and not only how to make a style transfer model, but along the process of transferring style, learning a lot of other useful stuff in Python, machine learning, and mathematics. So, first I will start with a video or videos which will explain the general architecture, concepts, and other things related to the model. Later, these videos will be followed by Python code explanation of the model. I'm assuming that you have a basic idea of machine learning concepts like loss functions, backpropagation, etc. The link to my code of the style transfer model is available in the description. The link for the original paper is also available in the description. We are going to look at style transfer based on this paper, Style over Content Loss. This image on the left is a photograph of a lake with trees and a path going through them. The image on the right is a painting by a painter called Claude Monet. He was French. I took the image on the left and put it in my model, and it generated this image in the middle, which has the contents of the image on the left, like green trees, lake, a path, but it has the style of the image on the right. This is called style transfer. The most common way of doing this is using a GAN. Let's call this image in the middle as stylized image and the image on the left as content image, because the contents of our stylized image are based on the contents of this image on the left. And let's call the right image as style image, as the style of the stylized image is based on the style of the right image. Remember these terms as we'll be using them all the time further in our videos. Let's look at these two paintings. Other than different style and brush strokes, there's one more thing which separates these two paintings. If we separate the content from these two paintings, it would look something like this. Now what we are seeing is the amount of content in both the images. The left one has high content, which means one can clearly see the outlines of the object which are present like branches, etc. But not in the right one. The right one is the content of Monet painting, and most of his paintings have very less structure and content in them. So, while teaching a model the Monet style, we would also have to teach it how much content and which content to preserve for the results to look like Monet style. For example, this picture on the left has lots of content, but while converting this picture to Monet painting, our model ignored all the contents except for branches, because Monet's style is Impressionism, where he removes the details and just keeps the rough structure. But how do we do that? How do we teach a model which content to preserve? Well, let's say we feed an input image with 3 channels, namely R, G and B, to a generator, which has an encoder, which is shown in pink, and a decoder, shown in blue. Remember that the encoder and decoder are collectively called as a generator. The encoder takes the 128 by 128 input image with 3 channels and turns it into low resolution 16 by 16 images with 256 channels. Here, due to space constraints, I have shown much less channels, but let's just assume there are 256 channels here. So basically, the encoder is throwing away information by turning them into low resolution small size images. Why is it doing so? Because the job of the encoder is to only preserve content of the input image and throw away all the non-content information. And so this 256 image approximately corresponds to this content information in this image. So let's call this 256 channel image, which is between encoder and decoder, contents of the content image. The decoder then takes this low resolution 256 by 16 by 16 image and upscales it back to a 128 by 128 by 3 image. This is stylized image, as said earlier. The function of decoder, as you see, is to add style on top of the 256 by 16 by 16 channel content image provided by the encoder. Just to recap, our generator is made up of two parts, encoder and decoder. The pink one is encoder and the blue is decoder. Encoder's job is to preserve the contents of the content image so that the stylized output looks like the input picture, but not preserve all the contents of the content image. We only need to preserve the contents of the content image which are important to our style. Decoder's job is to apply style to that preserved content and create a stylized image which looks like Monet. We need to teach or train our encoder and decoder for learning these two jobs. Job number 1, preserve the content of the content image which is important to the style. Job number 2, apply style to that preserved content.